In this video, I will demonstrate the effectiveness of PID gas control with the HERMS system configuration. I will select a preset program so I can speed through the process. Program 1 is a two-step program with a 5-minute rest at 1:35 and a 5-minute rest at 1:54, and now I will run the program. HLT temperature is at 172, strike temperature offset at 0, conversion check off, mash out for 5 minutes at 168, and a minimum sparge time of 5 minutes. I have the controller temporarily located at the bottom of the HLT so that I can record the actions of the controller and the burner. Notice that only the HLT output is on. I am running a HERMS system configuration that will be controlling with the mash temperature sensor and controller through the HLT output. The system is now approaching the pre-programmed step 1 temperature of 135 degrees. Ramp rate is roughly 2 degrees Fahrenheit per minute. In all cases, notification alerts and rest timers will start a half a degree Fahrenheit before the set point. I will silence the dough and alarm. At this point, we would be doughing in, and now I will start the rest. I will fast forward to the end of the rest to show the temperature stability and the beginning of the next ramp. I will now show the last minute of the Step 1 rest to demonstrate the temperature stability and burner operation for this gas PID controller. With a 30-second cycle time, burner ignition will occur once every 30 seconds. This will capture 2 burner ignitions before warm-up to the Step 2 rest. Notice that the mash temperature is maintaining a stable 135 degrees with the PID controller operating at a 30-second cycle time. We are approaching the second ignition. I will now fast forward to the end of the ramp. The system is now approaching the pre-programmed Step 2 temperature of 154 degrees Fahrenheit. The mash temperature will stabilize at 154. I will now fast forward to the end of the rest to show temperature stability and the mash out ramp. I will now show the last minute of the Step 2 rest to demonstrate the temperature stability and burner operation with this gas PID controller. With a 30-second cycle time, burner ignition will occur once every 30 seconds. This will capture 2 burner ignitions before warm-up to mash out. Notice that the mash temperature is maintaining a stable 154 degrees with the PID controller operating at a 30-second cycle time on gas. And I'll now fast forward to the mash out. The system is now approaching the pre-programmed mash out temperature of 168 degrees Fahrenheit. The mash out rest timer will initiate, and the mash temperature will stabilize at 168. At this point, I will fast forward to the end of the rest to show temperature stability and the mash out ramp. The system is now approaching the end of the mash out. The mash temperature is being maintained at 168 degrees Fahrenheit. At the end of the mash out rest, the controller will request if the mash heat is to be turned off. At this point, the controller will maintain the mash temperature at the mash out setting indefinitely until mash heat off is selected. Once the mash heat is turned off, the controller will switch from the mash temperature sensor and controller to the HLT temperature sensor and controller, and will ramp the HLT temperature to the pre-programmed sparge temperature of 172 degrees Fahrenheit. Notice that the mash out temperature is being maintained. I will now demonstrate the controller switch and select mash heat off. The controller is now ramping the HLT temperature to the sparge set point of 172 degrees. I will turn the mash circulation pump off. Wort is now flowing to the boil kettle instead of through the heat exchanger. Notice now that the mash temperature at the left of the display is falling off since we are no longer flowing through the heat exchanger. HLT temperature at the right of the display is increasing toward 172. Again, rest timers will start half a degree Fahrenheit before the set point. The sparge timer will start. Notice that once the temperature reaches 172, the HLT heat will turn off, demonstrating that the controller has switched from the mash PID controller to the HLT controller that I have programmed for on-off control. I am now going to fast forward towards the end of the sparge timer. The system is now approaching the end of the sparge timer. The controller will request if the HLT heat is to be turned off. At this point, the controller will maintain the HLT sparge temperature indefinitely until HLT heat off is selected. The HLT heat may be left on until sufficient wort has been collected in the boil kettle. The sparge timer is only used to prevent one from accidentally turning off the sparge heat and should be set to a value somewhat less than that, which is the usual sparge time. If you usually sparge for an hour, set the sparge timer for roughly 30 to 40 minutes so that if you collect enough wort early, you will have the ability to turn off the HLT heat when needed. I will now turn off the HLT heat. This concludes the demonstration of the Brewing Solutions Step Mash and HLT controller running PID control on a gas-fired HERMS brewing system. Have a great brew day.